Complete the square. So this is actually one of my favorites, complete the square. The idea is that if you have something like this, and I'm just making up numbers just to make a point. So this is a parabola, and you can very easily find the vertex. You just take the opposite of this number, and that's what x is going to be. And then the y is going to be the last number, or the number that's being added or subtracted, the 9. So the vertex is at 2, 9. You could then say here's 2 and here's 9. This is going to be the vertex, and then it would be a parabola going up like this. But how do you get it to be in this form? You guessed it, complete the square, because basically we want it to be in squared form like this, where I have the x minus 2 being squared. Of course, the 2 is not correct because I just made that up. Okay, now let's get down to this one. So first of all, instead of f of x, I'm going to call it y equals 3x squared plus the 6x plus 5. And notice that when I had it as x minus 2 being squared, if you multiply this out, it's going to be x squared minus 4x plus 4. The point being that this has to be just x squared. So that means that for the function that I have, I need to get rid of that 3. So divide all terms by 3. As long as you divide the left and the right side by the same thing, it's perfectly legal algebra. So on the left side, I'm going to have the y divided by 3. These, of course, are going to cancel, so that's going to give me x squared. For the x term, 3 will divide into 6 2 times, so this is a 2x. And then I leave some space and just take the 5/3 and move it over to the side. Now the next part for complete the square is whatever is sitting in front of x, you just go over to some scratch paper over here on the side, take that number, divide by 2, and then square the result. So 2 divided by 2, that means 1 gets squared, so that means it's equal to 1. So that means the number I need to factor is a positive 1. But if I add a 1 to into the problem, that actually changes the function. So what I need to do is subtract it right back out. So that's why I needed that underlined space. And I don't need it anymore. Then if you look at these 3 terms, that is where we can factor it as a square. And this one would be x plus 1 being squared. So I know that it's x plus 1 because whatever was in the parentheses over here, that's what goes in the parentheses over there. So since it was a positive 1, that's what goes in the parentheses. And if you multiply that out, you'll find out it does equal the x squared plus 2x plus 1. And then I need to find out how much is a negative 1 plus 5/3. Well, the negative 1, you could rewrite that as negative 3 over 3, and then plus the 5/3, that's a grand total of 2/3. And then let me just recopy the y divided by 3. And now we basically just have 2 steps left. One is at the end, I want it to say y equals. So multiply both sides by 3. And then it simplifies very nicely. It's y equals, and then 3 times x plus 1 squared. And then these cancel, and then plus 2. And then I need to verify and see if I did it right, make sure I didn't make any algebra mistakes. So I'm going to graph the answer that I just got, and then also the original function, 3x squared plus 6x plus 5. So go over to the graphing calculator and clear out these. So the original said 3x squared plus 6x plus 5. And then take a look at the graph, and it's this red parabola right here. There we go. And now graph y equals, and my final answer was 3 parentheses x plus 1 parentheses squared, and then plus a 2. And then this one's going to be blue. And unfortunately, I cannot see the blue one. So I think it's because of this app. So what I need to do is just turn this one off and then go back to the graph, and now I could see the blue one. And its vertex is at -1, 2. And if I go back to the y equals, and I turn this one on, turn this one off, and then look at the graph, and the vertex is the same, -1, 2. So then just go back to my work, because the directions did say find the vertex. So then the vertex, I did get it from the graph, but you basically just use the opposite of this number, so that's -1, and then whatever this number is, that's the y value. So there's the vertex.